In this short video, I'm going to walk through the formulation of problem 12 in chapter 5. This is an assignment problem. Assign students to different sectors to schools in sector B, C, or E. First, we need to define decision variables that Xij represents the number of students in sector I assigned to school in sector J. This is a shorthand. Alternatively, you can write all possible decision variables. I represents A, B, C, D, and E, J, B, C, E. Again, to shorten the notation, that Cij represents the distance between sector I and sector J, and I represents the number of students in sector I. After defining the decision variables, the objective function is quite clear: to minimize the traveling distance of all the students. Given the distance between I and J is C, and the number of students traveling to sector I to J, the distance is simply the product of Cij and Xij. But you need to summarize all possible combinations. So it's a summation. I is from A, B, C, and D, and E. And J is just B, C, E. There are certain constraints must be met in this problem. The school has limited capacity. Each school can only take 1,100 students. So the capacity constraint is Xij summation over I should be less than or equal 1,100. Another constraint is all students should be assigned to one school exactly. That can be represented by this condition, Xij summation over J. That means the students assigned to all possible schools in sector I should exactly equal the number of students in that sector. So here, need to pay attention is the relationship is equal, not greater than equal, not less than equal. If you use less than equal, that means some students are not assigned. And then last type of constraint is all decision variables should be non-negative. So this is a shorthand formulation of the problem, and you could alternatively write out all the decision variables. And that's the solution I given here. It will take some more time to write out the problem. After you formulate problem, we need to set up an Excel spreadsheet to generate solution. At this point, I hope you get some idea how to set up Excel spreadsheet skillfully. Let's look at the spreadsheet I set up. The spreadsheet has three parts. First part shows our decision variables, and the second area here represents the distance between sector A and schools. After those are given, we can find objective function value, which are some product of distance traveled multiplied by distance, given over here. After this done, we need to set up constraints. So remember that in solver, you need to have left-hand side and the right-hand side. First, let's look at the assignment constraint. All students need to be assigned. Here, right-hand side are all constant. It's the fact the number of students each sector has. The second type of constraint is a capacity constraint. So the data facts now are completed. The last step is to set up solver parameter. If C22, that's where you put objective. Problem is minimizing. Check minimize. Changing variable cells is where you put all the decision variables. That's B5 to D9. Constraints, if you lay out the constraint like this, you can do it in 2 steps. First step, you can set up the capacity constraint. You can use array to set up constraint. That will save you a lot of time. You need to set up constraints. Capacity constraint, you can set up in one shot using array. So cell B10 to cell D10, all should be less than or equal 1100. All students should be assigned left-hand side. Here is a E5 to E9 should exactly equal the number of students in each sector. Put it in cell G5 to G9. Check all the variables should be non-negative. Select simplex LP. You can Click Solve will generate solutions. The objective function value is 7,800. That's it for this assignment problem.